Hi CodingNomads, and welcome to this data analysis practice. I wanted to record a few videos to get your hands dirty, basically. The more you practice, the better, obviously. And I will try to be consistent, and I will try to struggle with you here, and hopefully you will follow me. This is going to be beginner's level, and I will try to be as slow as possible while I am doing this. And I want to follow a more structured way of doing this, so that's why I want to follow this textbook that I studied some years back. It's a great textbook from Cambridge University Press. I highly recommend. There are nice case studies here, open source, and we can use the data hosted over here to get started. For example, the first one I want to explore here is the Vienna hotels dataset. It's over here somewhere. Maybe I will struggle a little until I find it. Yeah, for each case study there are codes in Python, R, Stata, etc. And you can, but obviously I'm not going to follow their Python code. We will try to write our own, right? And Hotels Vienna is over here. Let's check. I need you to download this data and then read it with Python to start your analysis. That's the idea. And yeah, the access link is here. Let's see. I'm going to download it now. I need the clean version, this one. So if I click on it, probably there's going to be a download button somewhere. And I'm going to download it to my local. You can already start reading the data set over here and get familiar with the fields. I guess the city is Vienna all the time. Over here there are some stars, so each row is a hotel, okay? And you can see the neighborhood and some more information about the location in the city, how many times it was rated. They scrape this data from the web, okay? And each row is a hotel, and there is the information about the rating, stars, distance to the city center. That's going to be an important one. So this distance over here is the kilometer distance to the city center. And the city center in Vienna is that huge cathedral. There is a huge cathedral in the city center, and they measure the distance relative to that point. All right. Let's download and see what we can do with that. I'm going to click on the download button. And it's now in my downloads folder. I'm going to copy it into the project. By the way, I have an empty Jupyter Notebook project over here. It's totally empty. There is nothing inside. Let's create a new folder here and rename it data. I want to, of course this folder is also empty right now, but I want to copy that hotel CSV file into this folder. I'm doing that in my other monitor right now, and you should do the same. See, when I hit paste, you are going to see it here. So now it's available. Let's click on it. Well, it looks like complete garbage, right? This is comma separated values file, and these are the names of those fields you saw in the web interface. Of course, you see it in a beautiful shape over here because it's in a table format. However, when you download it, it's a CSV file and it looks like total garbage. We need to read it into our Python notebook, Jupyter Notebook, and work with it. That's the idea. And its relative path currently is that data folder. How to get started working with this? Generally, I mean, maybe 80% of the time or 90% of the time, the case in a real working environment will be similar. One of your colleagues might give you a URL, a path, maybe a connection to a database, and then you import the data and start working with it. Let's do that. Let's start a notebook. And maybe give a meaningful name. However, right now at the beginning, I don't know how to name it, so I will simply name it Sandbox. There are two main libraries that I will import, Pandas and NumPy. Let's see if the imports are successful. Yes, they are. Okay. Now I'm going to import the CSV file. I will do it using Pandas function called readCSV. That's quite straightforward. I'm going to create a variable called df, which is for data frame. Okay, and the readCSV function is in Pandas. If you press Shift Tab, you will see the documentation regarding this function, the readCSV function. The first thing it needs is a file path. Okay, and there are really a lot of arguments, parameters that you can pass to this function, and over time you will find them useful. However, currently in our first practice we just need the path. And how I did that is I just wrote file and then I hit tab and autocomplete opened, and then I hit enter and file path or buffer. So here I need to pass the path, and that path is the relative path to my home folder. And the name of that file is hotels Vienna. However, I will not type all of it. I will just write hot and then press tab and it will autocomplete. If it's not autocompleting, then it's a sign that the file is not there. So it should autocomplete the name. Okay. One thing I like is creating variables for my paths. So this is going to be a read path. Actually, let's cut and copy this string to this variable. Let's pass this here so that this will be equal to read path. When you create functions later, this will be handy. Generally speaking, they're going to be a reading path and a writing path. How it works is that you are always going to read something from a folder, and it's going to be the reading path, and it can be an input parameter to a function you will write in the future. And similarly with the writing path. Anyway, let's continue. Let's see if this small line works. It works. First thing I do is to check the first 5 rows, how it looks. Okay, it is very similar to the image we have seen on the web over here. There's a small important difference. There are 3 dots here, and sometimes it can be irritating because you are not able to see the columns in the middle. So there are some columns at the beginning, there are some columns in the end, but where are the others, right? In order to see them, we need to pass some options, some Pandas options. What I mean is that let's write a comment about it. add some Pandas options to be able to see all the columns. If you paste this to Google, you will get some recommendations already. And we can, Pandas show all columns will be here. There are several different ways of doing these things. Here I am just using one of the methods. This is valid also for the entire analysis process. There are several different ways of handling these things, and the more you practice, you will witness the more different techniques. Here this option is about setting the maximum number of columns that you can see. So set option, display maximum columns to, I would say, something like 100. This number should be larger than the number of columns you have. And how do you decide how many columns you have? There is a nice attribute here called columns. If you use this one and read all the columns and check the length of this list of column names, then you will see that there are 24 columns. So I could also write here something like 25. It would be enough, right? And the same with the number of rows. Maybe I want to see a maximum number of 50 rows when I use the head function, for instance. This is how you use these options, and they are quite handy. Let's run it from the beginning. See, now they are not hidden from me. I can read all of them, and it's a good sign. And this time it looks almost the same, like this one, right? Let's now explore these columns. For instance, the first thing I'm interested in is the information, basic information about this data frame. I call this info function and learn some basics about what I have in my hand, some ballpark numbers, if you will. For instance, there are just 428 entries in this data frame. It's a small data set, and there are nice field names like country, price. Price will be most important to me because I'm interested in the prices of these hotels. Neighborhood the hotel is located, how many stars it have, how many stars they have, and the ratings, right? There are some date and time related information as well. Nice. And yeah, I have object, float type, integer type. Nice. It looks like there are some missing records. Not all of them are 428. There are 428 entries. However, for some of them, the non-null records are smaller. There is another more concise way of looking at that. So generally I use this one. df is NA. So this shows me if there are NA, not available values. And I pass the sum function. So this is telling me there are 35 rows without a rating count, and there are 103 records without these two fields, and the rating itself as well, 35 missing values. Okay, we are learning more and more about the data, right? Let's continue. How did it look like? One more time. Okay. I'm wondering if there are any other cities other than Vienna. I will quickly check that. So this is how you select a column. If I run this, simply run this, it will give me the Pandas series of this column. And if you pass a function called unique, then it will give you the unique values in this field as an array. So in this case, there is only Vienna. It is the only city. All right. There is no other city. That's nice. How about the neighborhood? Okay, let's do the same with the neighborhood. The unique values for neighborhood. This time it's quite a lot. We have lots of different districts in Vienna, like Schönbrunn. I know a nice palace in there. Okay. But how many times these records are occurring for each neighborhood? Okay, we can copy this here, and instead of unique, we can use a function called value counts. You can again try to use the tab for autocomplete. If you write value underscore and then hit tab, it's going to autocomplete. That's basically what it is doing. Now this tells me more about these unique neighborhoods. This inner city has 84 records. Sometimes they registered it only as Vienna. The third most popular location is Leopoldstadt. Okay, interesting. Let's see what else we can do here. I told you that I am particularly interested in with the price. It's here. And I want to know, as a beginner, because I'm learning about this city, I want to learn about the average price maybe. And the first thing you can use is the describe function to have an overall understanding about the numeric values. This looks quite busy and there are lots of numeric columns, and we are looking at the descriptive statistics of these columns. However, I just want to see the price column here, not the others. I'm going to select it first. Okay, so again, there are different ways of doing this, but I will use this method. Now I can read it more clearly. So what this is telling us is that there are again 428 records for the price. The average price is 131 euros, and this is the standard deviation. I say it's quite high. The minimum price is 27 euros. It's interesting. I wonder where that is. And the others are 25th, 50th, 75th percentiles. We will come to that later. For instance, this 50th percentile will tell you the median value. And the comparison between mean and median can tell you about the distribution of the price. What do I mean by distribution is if you plot a simple histogram, because I want to understand how the price is distributed. Is it normally distributed? I don't know. but I can pass a quick hist function over here. And visually see that this is skewed to the right. It means basically skewed to the right. There are some extreme values here. There are some hotels much more expensive than the overall prices. Over here I see a price something like 1,000 euro per night. There is some records with 800 euros. So these are skewing the distribution to the right hand side. That's why I say skewed. You can recognize this distribution, the shape of the distribution, also from the describe function. If your average is higher, much higher than the median, it means it is skewed to the right. It means there are some extreme values pulling the average price to the right hand side. Okay, that's what I mean by skewed. Cool. Now we have an overall very starting level understanding about the prices in Vienna. Interesting. I just want to include one more variable here. I want to see also the distance to the city center, because I'm interested in comparing different hotel prices based on their distance to the city center. The minimum value is 0. I guess this hotel is located on top of the cathedral, or very close, let's say. And there is a maximum of 13 kilometers. The standard deviation is here. On average, it is less than 2 kilometers. Okay, and this time, see, the median is smaller. Okay, so I have an overall understanding about the price and distance. I want to see their relationship, preferably on a chart. Let me try to do that. So, as a Pandas data frame, so if I select my columns with 2 brackets, it will come to me as a data frame format, in a data frame format. Up over here, I demonstrated, if you remember, with single bracket. If you use one single bracket, it's going to be a Pandas series. With 2 brackets, it's going to be a Pandas data frame. See, this is the difference. This is data frame format. Cool. I want to see here the data frame format anyway. Here we can quickly pass visualization functions to Pandas data frames. Just like I used histogram here, I can use different methods. Using this dot notation, I can call different visualization functions. These visualization functions actually runs with Matplotlib under the hood. Matplotlib is a visualization library that you will need most of the time. And in fact, you need to import it at the beginning over here. Import matplotlib pyplot as plt. Let's run this so that we have the matplotlib also available in our environment. Okay, well, what's happening if I simply say plot? Let's go ahead with trial and errors. Okay, if I simply say plot, what's happening? It's simply plotted as a line chart. The blue is the price as a line chart, and the orange is the distance as a line chart also. This looks like garbage to me at the moment, because I want to use a scatter plot. A scatter plot will be more meaningful when I plot distance versus price, so that I can see how the price is changing when the distance is a parameter that can explain the price. hopefully. And you can use the official documentation all the time to understand how to make these scatter plots or bar plots. You will need to write pandas, not show all columns, but pandas scatter plot. This is the place to go. Always check the official documentation first. Randomly Stack Overflowing will harm you in the long run. I'm not saying don't look at Stack Overflow, it's useful, but reading documentation is more useful. So this is the method to use. Dot plot, dot scatter. It's quite straightforward, right? Dot plot, dot scatter. So the way it works, so over here they are stating that there should be a pandas data frame first, and then on top of this object you will be calling these functions with dot notation. So give me a plot which is scatter. That's how you can read it. If I simply run this without using anything, what would it say? Okay, it says it needs two required positional arguments, x and y, which is also stated here. It needs x and y to be able to plot this thing. And the self over here is the data frame itself. It is stating that the data frame is also being passed into these functions. But since you are already using it at the beginning over here, it is passing this data frame object to these functions. That's what self means. Okay, I need an x. The x variable will be the explainer, the potentially explainer, let's say. And explainer of what? Explainer of the price. So that's distance. And the target variable in this case is price. It's target variable because I want to explain the price. I want to know how the price changes, if you will. Let's see what it says. It says, okay, positional argument, all right. What's going on here? What's going on here is that I didn't use the y. That's why it couldn't understand what I was doing. This is a much better view of what's happening regarding the price. Again, the distance as the explainer here. We can see also visually that most of the hotels are within 2 kilometers. That makes sense. There are also some extreme distances. I have this very expensive hotel here, the 1000 per night, and the 800 here, 800 per night here. Generally speaking, I feel more comfortable when my charts are larger and easier to read. Let's do that. I'm going to pass, or I will try to pass. I will see if it's failing or not. So I want a figure size 20 in x-axis and maybe 6 in y-axis. This is the size. Yeah, it works. And for me, this is much better and readable. I want also a title. The nice thing about using Pandas visualization and Matplotlib visualization is that you can use Matplotlib functions directly inside. So this plt title will add the title manually, and I'm going to call it distance versus price. Let's see if it works. Yeah, it works. So this is something that you can right click and copy into your presentation or anywhere. This is something you can save also somewhere. You can also save programmatically, but you can quickly use these charts to communicate with your colleagues or your friends, etc. If you don't want to see this irritating text over here, you need to pass this plt show function here. It's up to you. In Jupyter environment, you don't need to pass this function to be able to see the result. However, it will print that irritating text. Fine. Since these two hotels, this 800 hotel and 1000 euro hotel, are extremely larger than the population, I'm wondering what kind of hotels they are. And let's formulate that as a question. It's a best practice to formulate some questions and then answer them, because a problem well defined is a problem half solved. And in here, this is a code chunk. I can convert this to a markdown and write down my question as a text. The most simple way of doing that is selecting the markdown here in the drop-down menu. Okay, and then write whatever you want. Like, here is my question. If you run this, this will stay as a text over here. The nice thing about markdown is that you can style it, and knowingly, sometimes you see nice documentation on the web. Chances are, most of the time they are in markdown format. If you use a hash, it's going to be a huge title, and you can play with the size like this. And instead of writing here is my question, let's write a real question. What are the most expensive hotels? See, we are doing exploratory data analysis here. We are learning what's going on in the data still. And as a data analyst or data scientist, or however it's called, more than 90% of the job is this, basically understanding the data, transforming it, and then after some time you may start modeling it. However, when you are doing exploratory data analysis, knowingly or unknowingly, you are doing some modeling inside your head, right? Because, for instance, if I would have a linear regression model, let's say, I would fit it into this data, right? And I would need a line or a curve that fits inside of these dots. And it's going to have a mathematical notation as well. Our brains are actually great visualizers. So I can imagine a line going through these dots, and it can be a model, maybe a linear model, who knows. But anyway, these are running in the background while we are working. Similarly, at the beginning, we saw that the price is right skewed, and immediately we start thinking, what to do with this. Anyway, for the time being, let's see the expensive hotels. These kind of questions will help us to learn more and more about the data. First, let's check the first 5 rows again. Yeah. I always like seeing my data first, and I want to filter and see the hotels with price greater than 700 euros. So let's formulate it here. The price greater than 700 euros. See? Now I have a more clear question. And You already know how to select the price column. This is how you will select, and the ones I need are the ones greater than 700. Okay. However, if you run this, let's run this, this will give me something strange like this. These are Booleans, so, and how we will filter the data will be by using Boolean masking. False means in these rows there is no price greater than 700. If there is, it would be true. And I think in this data there are 2 records with true. I will use this as a condition, so I will say that this is my cont, standing for condition, and I'm going to pass this to my data frame like this. In this case, this is called Boolean masking, and it will give those 2 rows where you have the price greater than 700. These are 2 hotels in the city center, inner city and the Neubau. All right, the 806 euro and 1012 euro. One of them is 5-star hotel, and interestingly the other is 3-star hotel. And probably it has a beautiful location. Cool. It's hotel and their ratings are high. How about the distance? Distance should be also small based on the chart I have seen. But where is the distance? Okay. Of course, it's in the end. 1 kilometer and 300 meters, I guess. 300 meters. It's directly close by to the cathedral. Okay, we know now the most expensive hotels. And let's formulate another question. And try to be consistent with your styling. So I used for hash again, just like I used above. And I would say, what is the average price per neighborhood? Neighborhood. Let's see how we can answer this question. There are again different ways of doing this, but let's try a method here. I'm going to try first selecting the price and neighborhood, right? First I will select this data frame and then I will group by. Oh, I don't want to write it again. Let me copy. Group by neighborhood and get the average per neighborhood. I am using these parentheses at the beginning and in the end to be able to use this pipelining method. See? So when it is in this scripting format, it is easier to read for everybody. First, I am selecting my columns, and then in the second row I am grouping by neighborhood and then taking the average. Let's see what this can print. Nice, these are the average prices per neighborhood, but I want to have it more readable, maybe in descending format. And over here I don't want to see price anymore, I want to see average price. let's see how we can handle with this. I will simply add more methods to the pipe, such as rename columns. In this case, renaming will need a dictionary, so the price will become the average, or let's call it AVG price, or price AVG is better to my view. Price AVG. Let's run this again and see what's happening. Okay, this is good. Now I want to sort values by price AVG. Let's run this again. Cool. But I want to see it descending. Ascending, false. I think there is an S needed here. Okay, now this is what I wanted to see. This is the neighborhood with the largest price tag, and then the second, and then comes the inner city, and then Neubau. And if you want to visualize this, what you need is to pass another plotting function, just like we did above. And if you simply hit plot, it will give you a line chart, which is not a good idea in this case, as you can imagine. What you need is a bar chart, because this is categorical data and you are comparing the average prices. Then you need a bar chart. Definitely do not use a line chart if the data is not continuous. For the continuous data, you can use line chart. Just like we are using the scatter over here, instead of scatter, we can pass plot bar, in my opinion. Let's try that. Plot bar. Cool, getting better. Again, we can play with the size a little. Fix size. Again, 20 by, I don't know, 6. Would it work? See, now I have it in table format and in visualization. If you comment this out, you will get the table. If you use the plotting line, then you will get the chart. Now I will give a break here and continue modeling this data, because we learned quite a lot about this data. This was our first beginners level understanding regarding this data that we found in this website from this textbook. We created Pandas data frame. We explored what kind of columns we have. We explored our missing values inside of this data. We started exploring the variables of interest, like the city, neighborhood, the price, how it is distributed. Is it normally distributed, skewed? What are the basic statistics? What is the minimum, maximum value, the median, etc. And then some basic visualization to understand the relationship between the price and the distance. And then, of course, exploring some expensive hotels and see where they are, how they look like. And finally, we grouped by neighborhood, and we found the average price by neighborhood, both in visualization format and data table format. Now, we will continue this, and we will try to create our first linear regression model in the next one.
Hey everyone, thanks for watching. If you enjoyed this video, please let us know by liking and subscribing. If there's another topic that you'd like to learn more about, leave us a comment. We would love to hear from you. And if you want to become a coding pro, visit our website at codingnomads.co. See you next time.